Okay, so we have our measurements here. We have our mass of our hydrate sample, that's that 1.2 up there. We have the mass of the dehydrated sample, 1.02, and we have the mass of the final copper of 0.477. Okay, I actually didn't bother to write those down because they weren't necessary for this. Those are the three masses we actually need. So I just left them off there to make this paper look nicer. Alright, so we're going to start just going right in an order. We can get the number of moles of copper because we do have the mass. And what we're going to do is just take that mass and divide it essentially by the molecular weight. And that gives us 0.00751. Alright, to get the mass of the water evolved, we're just going to take the mass of our hydrated sample minus the mass of the dehydrated sample, because that's the only thing that's left there is that's cooking off the water. So 1.283 minus 1.022 is 0.261 grams. We're going to do a similar thing for the moles of water. I'm going to take that 261 and now we'll just use the molecular weight of water. .261 divided by 18.016 is 0.0145. Alright, and then the last mass is chlorine. We have the dehydrated sample, which would be just the copper and chlorine, and we do know the mass of the copper, so we can subtract this from the 1.022, the dehydrated sample, minus the mass of just the chlorine, or sorry, of the copper. That would give us just the mass of the chlorine. And we'll do yet another convert to moles. .4545. And we get 0.0154. Alright, the next thing we're going to do is get the actual ratios of chlorine to copper, and then copper to just the water. So, being that copper is the second one on both of these, we're going to just take our, for that first one, the moles of the chlorine, 0.0154, divided by the moles of the copper, 0.75. And just looking at that, I can see that's almost 2 on the nose. Ooh, yeah. Now, we could write all those numbers, but we are looking for a whole number ratio. I'm going to say that's close enough to 2. I'm just going to say it is 2. And now we're going to do something similar, but now we're going to use the moles of the water compared to the moles of copper. And that's also pretty darn close to 2. Ooh, 1.93. I'm going to say that's 2 as well. Now, I will tell you this, if you get a chance to do this in the actual lab here in Florida, I had the advantage of using a brand new sample. It hasn't absorbed extra water. Turns out most of the time our chemicals are slightly damp just because our humidity level is relatively high. So, me getting those nice whole numbers really did translate to having the nice stuff to begin with, so very nice and dry. Alright, but I can actually come up with a formula here. So that dehydrated sample, which is just copper and chlorine, would actually be CuCl2. And then the hydrate sample has 2 waters for every single copper. So it is CuCl2 dot 2H2O. When we say that, the name of these, it's copper 2 chloride. And the second one would be copper 2 chloride dihydrate. Modern naming, sometimes you'll see it called a 2-hydrate. So they're not using prefixes always anymore. Sometimes they're just saying what the number is. Alright, but I'm very happy with the results. That's much better than I was expecting on this lab.